In this video, we will explore recursion in the C programming language. We will understand what recursive functions are, and also look at some of their practical applications. Recursion is a programming technique where a function calls itself to solve a problem by breaking it down into smaller instances of the same problem. Here is an example of a simple recursive function. This function is called countdown. It takes an integer n as input. If n is less than or equal to 0, it prints blastoff. Otherwise, it prints the value of n and then calls itself with the argument n-1. This is a recursive call. Let's discuss the essential elements of recursion. A base case is a condition to stop the recursion. Without a base case, the function would call itself indefinitely, leading to a stack overflow error. The recursive case is where the function calls itself. This is the heart of the recursive process, where the problem is broken down into smaller subproblems. Progress towards the base case is important. Each recursive call must move closer to the base case. This ensures that the recursion will eventually terminate. A stack frame is memory allocated for each recursive call. It stores the function's local variables and the return address. The return value is the result passed back up the call chain. Each recursive call returns a value, which is then used by the calling function. Here's a diagram that illustrates how the countdown function works. The countdown function is called with the value 3. Then the countdown function is called with the value 2, followed by 1 and finally 0. When the countdown function is called with 0, the base case is reached and the function returns. This stack frame visualizes the call stack for the countdown function. A common example of recursion is calculating the factorial of a number. Let's see how that works in C. Here is the code. The factorial function takes an integer n as input. This is the base case. If n is less than or equal to 1, the function returns 1. This is because the factorial of 0 and 1 are both 1. Otherwise, for the recursive case, if n is greater than 1, the function returns n times the factorial of n-1. Here's how it works. The base case states that when n is less than or equal to 1, the function should return 1, since 0 factorial and 1 factorial both equal 1. For the recursive case, when n is greater than 1, we multiply n by the factorial of n-1. For example, factorial of 4 is equal to 4 times factorial of 3, which is equal to 4 times 3 times factorial of 2, which is equal to 4 times 3 times 2 times factorial of 1, which is equal to 4 times 3 times 2 times 1, which equals 24. Another classic example of recursion is generating the Fibonacci sequence. Here is the code. The Fibonacci function takes an integer n as input. If n is less than or equal to 0, the function returns 0. If n is equal to 1, the function returns 1. These are the base cases. Otherwise, for the recursive case, the function returns the Fibonacci of n-1 plus the Fibonacci of n-2. Here's how it works. The base cases are that f of 0 equals 0 and f of 1 equals 1. The recursive formula is f of n equals f of n-1 plus f of n-2 for n greater than 1. For example, Fibonacci of 5 is equal to Fibonacci of 4 plus Fibonacci of 3, which is equal to Fibonacci of 3 plus Fibonacci of 2 plus Fibonacci of 2 plus Fibonacci of 1, which equals 5. Let's examine the advantages and disadvantages of using recursion. Recursion offers elegant and concise code for complex problems. It provides a natural solution for recursive data structures like trees and graphs. It simplifies problems with recursive mathematical definitions and can be easier to understand and verify for correctness. It also reduces the need for complex loop structures and state tracking. However, recursion also has drawbacks. It incurs higher memory overhead due to stack frames and carries the risk of stack overflow for deep recursion. It's often less efficient than iterative solutions. It has the potential for excessive function call overhead, and debugging can be more challenging. Weigh these pros and cons when deciding whether to use recursion in your programs. Recursion is a powerful tool with numerous real-world applications. Here are some common use cases. Tree traversal algorithms, graph traversal such as depth-first search, divide and conquer algorithms, backtracking problems, parsing expressions, directory and file system operations, and dynamic programming problems. Let's look at an example of binary tree traversal. Here's the code. We have a struct called node which has an integer data, a pointer to the left node, and a pointer to the right node. The in-order traversal function takes a pointer to the root node as input. If the root is not null, it recursively calls in-order traversal on the left node, then prints the data of the root node, and then recursively calls in-order traversal on the right node. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.